Hello guys, welcome to Solving Solutions, your number one channel where you get solutions to all your solving problems. It's nice having you in class again today. How have you been? How has the new year been with you? Hope you've been getting along very well. On today's video, we are going to show you something on adjustment computation again. And then what we are going to consider is a leveling loop or a leveling network. We want to adjust the height of a leveling network. Now you can see on the question we have adjustment of a leveling loop, and then this was actually a diagram, would I say a sketch. Please pardon some of those typos you can see there. This is actually a sketch of how the leveling loop went, and then we have the change in elevation between the points. So the question was that we should determine the most probable values of the elevations of Q, R, and S. So before we proceed, if you have any issue related to this, you can always contact us and then we'll get back to you as soon as possible. And again, we want to say a very big thank you to one of our bosses, our lecturer, a lecturer's lecturer. So I want to formally appreciate Surveyor Olaniyi Saga Said. I hope I didn't make a mistake. Okay, Surveyor Saga Said Olaniyi, right? Yes, we want to say a very big thank you to him. He's a lecturer at the Federal School of Surveying, Oyo. We want to thank him for his contribution towards this video, because he actually made a very big contribution for us to be able to come up with this video. Thank you very much, sir, for always coming through for solving solutions. Now let's look at the question. So they said we should determine the most probable values of the elevations of what Q, R, and S. Now you can see from the question, okay, we did not write the elevation of P that was given to us. The elevation of P that was given to us is actually 150.020 meters. Please, the elevation of P given to us is what? Let's say we have P equal to 150.020 meters. Now this is actually the benchmark that was given to us. That is what the elevation of this point here. Are we together? Good. Now we are given the elevation of point P, which serves as our benchmark, and we want to determine the elevation, the most probable values of the elevations of what Q, R, and what and S, and we are given the change in elevation between those 2 points. Now the first thing is what? The solution. The first thing is that we are going to determine the observed height of points Q, R, and S from P. We are going to determine the observed heights of Q, R, and S of what? From point P. Now why are we doing that? You know, most of the times when you want to carry out level, you move from a known point to an unknown point, right? Good. And then conventionally we defined it as to determine the change in elevation between 2 points. These are 2 points, right? P and Q, or P and S, or P and R. So we are trying to determine, this is Q, S, R, right? So we are trying to determine, we already have the change in elevation. So what leveling does is that it helps you know the change in elevation, and with the change in elevation you can actually determine the elevation of the next point. So since we have the change in elevation, we can actually get the observed elevations of these points. And what is the essence of adjustment computation? The essence of adjustment computation will now be for us to reduce to the barest minimum the error that is inherent in those observed heights. So that's what we are going to do. So the first thing now is that since in the question we were not given the observed heights of these new points, we are now going to use our change in elevation to determine the observed heights of those new points. So with those observed heights, we can now be able to form some other matrix subsequently in the video. Are we together? Good. So now from the notes there, we say let's determine the observed height of points Q, R and S from point P. Good. Why are we saying we are trying to determine the observed height of Q, R and S from point P? The reason is because if you look at the network, you can see that these Q, R and S are all connected to point P at one point or the other. This is Q to P, this is S to P, and then this is R to P, which means you don't really need to go this way, you don't need to go this way. All you need is that since we know P, right, we know the elevation of P, which we've actually written as 150.020, we can actually connect it with Q, we can connect it with R and with S, and we can also connect it with what, with R. That's why we say we are going to determine the observed heights of point Q, R and S from what, from point P. This is because P is connected with the other points by direct observation. By direct what? By direct observation. So now let's proceed. Good. So this is where we now proceed. The elevation of P given is what, 150.020, and then we want to get the elevation of Q. Are we together? We want to get the elevation of Q. Now, how do you get the elevation of Q? Let us look at the relationship between P and Q. According to the network, or according to the diagram, the leveling is moving from Q to what? To P, right? Which means you moved from this point to this point, and you have this change in elevation. Now, by this simple formula we have here, we know that change in elevation is actually the change in H1 is actually the difference in elevation between 2 points. And according to the arrow, or according to the direction, because this arrow is very important, when you're trying to draw a leveling loop, you must ensure that you get the arrows right, because if you mistake, or maybe if you change the direction of the arrow, it will actually affect what, your result. Good. So since the direction of the arrow goes this way, it means that the leveling is moving towards this direction. Therefore, the change in elevation will be where the direction is going minus where it is coming from. Are we together? Since the direction goes this way, then it means this second point minus what, this first point. That's why you can see we have something like what, change in H1 equal to P minus Q. Are we together? That's why we have what, change in H1 equal to P minus Q. Now, this is something you need to pay very good attention to, so that you can get it once and for all. We can say it's actually in the basics of leveling. However, we need to just pay attention to it at this point, so that we understand how this direction works. So since the direction is going towards this point, it will be this point minus what, this point. So you now see something like change in H1 equal to P minus Q. So we are now trying to do a little bit of change of subject of formula, right? We want to make Q our, would I say, the subject of this formula. So what do? Q is already having a negative sign, so minus Q will now be what, this P will cross over to meet change in H1. These are actually basic mathematics, right? So we now have something like Q equal to P minus what, H1, change in H1. So this is actually basic mathematics. So if you try to listen very well, you get it as fast as you can. Very, very simple. So Q will now be what, P minus what, change in H1. So you already know that our change in H1 as given to us from the question is what, 6.226 meters, right? So 150.02 minus 6.226 should give you 143.794. So this is the observed, or the provisional height of Q. Are we together? So that's for Q. Now let's move to the provisional for R. Now let's come back to our diagram. From our diagram, you can see that what, the relationship between P and arrow is on this line, right? And you can see that the arrow is still moving towards R, which means we are coming back to what, arrow minus P. Is that not good? So we are coming back to what, the height of arrow minus the height of P. So that brought us to this formula, and this line is actually what, for change in what, H6, right? Change in H6. So we now have this line. So we come back to our formula. So change in H6 is equal to what, arrow minus P, right? So this implies that our arrow here will now be this change in H6 plus P, because this has a minus sign. So when it crosses the equality sign, it turns towards positive, right? So it now becomes plus change in H6, and then our change in H6 that was given to us from the question is what, 17.275 meters. So you add that to the value of P, which was given to us, the benchmark 150.020, it will give you the provisional, or what, the observed heights of what, R. Same thing happens to S. What is the relationship between S and P? Let's check it out. Now the relationship between S and P is what, this line, which is what change in what h3. So if you look at it closely, you see that it is going towards p, which means we are coming from p to what, to s in this case. So it will be what, p minus s, right? Good. So we now have what, and then it's actually change in h3. So we now have what, change in h3 will be equal to p minus s, right? So our minus s, because this s has a negative sign, will actually be change in h3 minus p, because it's crossing over to the other side. But what we need is a positive value. So when we use the minus to multiply through the equation, we now have what, s equal to, this will change to negative and then this will change to positive. So we have what, p minus what, change in h3. So our p is constant, then the change in h3 given to us from the question is what, 11.368. So 150.02 minus 11.368 will give you something like what, 138.652. Good. So now, when as we have gotten the observed heights of, or the provisional heights of the 3 points, we can now move to start what, forming the observation equation, right? Let's now form the observation equations. So now the idea of forming the observation equations are still very simple from what we have explained earlier. If you look very closely, you would see the directions as we have talked about. Now let's say change in h1. The formula still goes as change in h1 adjusted is actually equal to the height of p adjusted minus the height of q adjusted. Now this is change in h1, right? Which is the height of p adjusted minus what, the height of q adjusted. And you already know that p is a benchmark, which means it doesn't have an error. So this means when we want to open this bracket, or when we want to expand this expression, we have something like what, changing the height of p rather observed without any error. Remember that p does not have any error because it's what, it's a benchmark, minus the height of q observed plus the error in q. Remember that q is not a benchmark, therefore it has error, but p is a benchmark, it does not have any error. So it will not have any error in this what, in this formula or in this expression. Are we together? But q, since it's not a benchmark, it's one of the heights we want to determine its most probable value, therefore it has what, this error. So plus the error in q. So when you open this bracket, you have something like minus opening the whole of this bracket. So you have what, the height of p observed minus the height of q minus what, the error in q. Are we together? Because this minus here has actually changed this plus to minus by opening this bracket. So when you now add these two values, when you subtract these two values, the height of p, which is the 150.020 minus the height of q observed. Remember, we are dealing with the observed values now, which is actually what, 143.794. So you would have something like 6.226 minus what, this the error in q. Are we together? These things are very, very simple. You can take your time, you pause the video, you get it, and we believe you are able to, you will get everything once and for all. Now let's move toward change in h2 adjusted, the same way we have moved. Now this is change in h2, right? This is the direction, so it means it's coming from q to s, right? Q to s, q to s. So now since it's coming from q to s, according to the formula, it will now be what, the height of q adjusted minus the height of what, s adjusted. Now these two points are unknown, therefore they have their errors inherent in them, right? So we have the height of q observed plus the error in q minus the height of s observed plus the what, the error in s, right? So when this minus tries to open the bracket, we have something like this minus will now change this change in s to minus, and it will also changes the error in s to what, to minus. So we now have what, the height of q observed minus the height of s, because of this minus has opened this bracket, then plus the height of q, which is still positive, minus what, the height of s, because this minus has what, opened this bracket. Are we together? So that's how you carry out what, the expansion. Now without spending much time, let's just move to the last point, because it's the same process we're going to use for all of them. Now change in what, h6, right? Change in h6. Now let's look at our loop. According to our loop, change in h6 moves from what, from p to r, which means we are coming what, r minus p, right? Good. So we have something like the adjusted height of r minus what, the adjusted height of what, p. So since we know that p does not have any error because it's actually our benchmark, it's only r that has error in this case. So we have what, the height of r observed plus the error in R minus the height of P observed. Are we together? So in this case, we just have this minus here. So this minus comes to meet its partner here, which is the height of R. So we have the height of R observed minus the height of P. So all these heights we are talking about in a case or in the situation where it is either Q, R, or S, we are using the provisional or the observed heights we have gotten here. Are we together? So that's how you form the observation equations for all of them. Now we consider the A matrix. We consider the A matrix, the coefficients of these unknowns, or whatever we want to call them, these error. So you look at the first equation, we have 6.226 minus changing the error in Q, right? So since we have the error in Q in equation 1 and it is negative, so we are representing, or we try to indicate it with -1, and there is no arrow, there is no S. That's why you see 0, 0 for arrow and S. Are we together for equation 1? Let's move to equation 3. If you look at equation 3 now, you see 11.368 minus change in S, which means there is no arrow and there is no Q, and the S we have is negative. So you see now that for equation 3, there is no Q, there is no arrow, but we have S, which is actually -1. Are we together? Good. Let's now move to equation 5. We are just taking them randomly, but we know you should be able to get all of them at once. So now we have 28.643. Please, you need a calculator by you. So we have 28.643 plus, you see now we have arrow and S here. The arrow here is positive minus the S here is what? So the arrow is positive and then the S is negative, which means there is no Q here for equation 5. So let's see, there is no Q here. You can see there is no Q, but the arrow is positive and the S is negative. So that's how you form your A matrix. Are we together? Now let's come to our L matrix. Our L matrix is very simple: the computed minus the observed. In this case, the computed will be all the heights you got here while you're carrying out your calculation. That's why we say you need a calculator. And then the observed will be these observed values you already have here, or the change in H that was given to you. Are we together? That you've seen on the other that you saw on the other would I say material or the other note. So you now subtract those values. Let's say for instance now we have 6.226, right, minus the change in H1 given to us, which is 6.226, so it's 0. Let's now come to the second one that is not giving us 0. If you look at your if you remember, or maybe if you just go back to the first sheet, you will find out that for the change in H2 we are given 5.133. However, when we did our subtraction, when we did our computation, we are having 5.142, which means the computed is 5.142 minus the observed, which is 5.133. So you should be able to have this 0.009 as the value there, the difference there. So same thing as the fourth one, which is actually another value. Let's come to change in H4. What we computed here is 23.501. However, what we observed is 23.521. So when you carry out the computation, you will find out that we are having something like this is the computed minus the observed. You now have a negative value of this. So this is how you form your L matrix. Are we together? It's very simple. We have other videos in this series that we are going to leave the link on the description section so that you can also appreciate the build up to this point. Now, since we already have all the matrices, we are now going to use this formula. The formula we are using, this D, or let's say the error, or whatever we want to call it, is equal to A transpose A inverse multiplied by A transpose L, right? Good. So A transpose A inverse multiplied by A transpose L. So by that we simply mean that we are now trying to get the transpose of A multiplied by A, then we'll get the inverse, then we also have the transpose of A multiplied by multiplied by L. Then our most probable value will now be the observed height plus whatever answer we are going to have here. So this minus is actually part of the formula. When you see the other videos on this series, you will understand how we explained this minus. Now we are going to use Excel, which we are going to share the screen with you very soon, on how to, we have actually imputed the values. So we are going to show you from Excel how to just carry out this calculation to get the most probable values of these Q, R, and S. So now see you on Excel very soon. All right, now you can see on the Excel we have actually imputed all the values. Remember, we have other videos on this series, so you can always check them out. The links to those videos will be on the description section of this particular video. So this is our A matrix. Remember, we had a minus 1 0 0 because on equation 1, or on the observation equation 1, yeah, we have only Q, and the Q is what? Negative. There is no arrow, there is no S. So this is what? Matrix A. Now, transpose of a matrix, we have told you how to do that, but for the sake of explanation, let's just still do it. This is the array, and then we have equal to, so we have what? Transpose, right? So we just type transpose, which is this, and then we want to what? Transpose this matrix, so we have something like this. Oh, sorry for that, this array is not complete, we need three more. 3, good. So equal to transpose, right? Good. So we have what? Transpose as this. Then we now select all of this. Then Control Shift Enter. We have what? Transpose of that matrix. Are we together? So that's how you get the transpose of the matrix. Then how do you multiply matrices? Since the basics still on the video, on the channel rather. Now the basics is that when you want to multiply two matrices, the rows in one must be equal to the column of the other. So when you look at these two matrices, A and what? A transpose, you can see that we have 6 and 3, and then 3 and 3. So we can 3 and 6, and then 6 and 3. So we can either have a 3 by 3 matrix as a product, or a 6 by 6 matrix. But we are going to have a 3 by 3 matrix. So we just define a 3 by 3 array, which is equal to, then the next function is what? M mult, which is what? Matrix multiplication. So what's the order? The order is what? A transpose multiplied by A. So we have what? A transpose, then comma, what? Multiplied by what? A. So how do you go? Shift Control Enter. So you have what? You have the product of these two matrices. So you can now see that they are actually corresponding with what we already had earlier. Are we together? Then how do you get the inverse of a matrix? The same thing. So since this is a 3 by 3 matrix, the inverse will still give us a 3 by 3 matrix, right? So we have what? Equal to, we define the array, then we have what? M inverse, right? So we have M inverse, which is this, right? So M inverse, then we now select all, we select all, then Control Shift what? Enter. So it has returned what? The inverse of this matrix. So you see, it's very easy to use Excel for it. That's why we had to move from the note to what? To Excel, so that you can see how fast and how easy you can move on with what? Your process. Are we together? So with that, the next part of the formula is what? We are going to, this is our L matrix. Remember the computed minus observed. So this is our L matrix. So you should be able to check this if what you got from your calculation actually corresponds with this. So A transpose times L, the same L mult. How do you do that? A transpose, which is this A transpose, multiplied by this L, should be able to give you what? This 3 by 1 matrix. So finally, our D is giving us this. So what's our D? Our D is actually what? A transpose inverse, which is this product, multiplied by what? A transpose L. Are we together? So now let's just check it out. So we still have 3 by 1 array, right? So let's just define a 3 by 1 array. Please ensure you do these things yourself, because that's the essence of this video. That's the essence of bringing it up to this point. M mult, right? So we have what? A transpose A inverse, which is actually this, right? A transpose A inverse, then comma, A transpose L, which is this, right? Good. So Control Shift Enter. So we have what? We have the product. So this is D, which is this final answer. But remember that there is a negative sign attached to the formula. Therefore, you are going to multiply everything you have here with what? Minus. So we just say equal to minus this particular cell. Enter. So it has changed it. We can just what? Now autofill. Just drag it down. It will affect all of the others. Are we together? Are we together? Good. So that's how you just move with the process. That's how you what? You move with the process. So that's the same thing as this particular column. So the final part, which is now the adjusted height of each of those points, will now be, since we already have the observed height, which we calculated using the benchmark. Remember that that of Q was what? 143.794. That of R was 167.295, and then that of S was what? 138.652. Therefore, the most probable values of Q, R, and S, these are actually the observed, right? as we got from the observation. Now, these are now the what, the most probable value. How then do you come about this most probable value? Since you already know what these error are, you now add this error to this our observed height, which is actually what you can see here. So now let's see how it goes. So this is equal to, since these are our observed values, plus this one we have these particular values whose sign will change by multiplying with what, minus. Are we together? Plus this. So we just say enter. Are we together? So you now just autofill. When you autofill, you will see something like this. So this is actually the same thing as this. When you reduce it to what, three, what do you call it again? The three decimal places. Or good. So good. So you can now see that these are actually the most probable values of what? Of Q, R, and S. So it's actually quite a long process, but we tried our possible best, or we tried our best to reduce it as much as we can and also be exhaustive as much as we can. So this process is very simple. You just take your time, you pause, you rewind, you get the whole picture, you come back again, and you build on everything that you've done. So once again, we want to say thank you to our resource person, our lecturer, Sovio Said Olani Saga, for his contribution, and to everyone that has contributed one way or the other to whatever the host of Solving Solution knows. We are saying a very big thank you. But thanks for coming to class. We are going to see you on our next video. Make sure you learn very well. Make sure you observe very well on site. And have a nice time. Bye.